Hello and welcome back to the second lecture of week 3 on research methodology. In this lecture we'll be talking about analyzing data and I'll be using the program SPSS to guide you through some data analysis. What is SPSS? SPSS stands for Statistical Package for the Social Sciences and is typically used for most statistical analysis you see the results on television, radio or anywhere in the media. It is as famous as a Microsoft Word is for word processing. What it does is that it allows its users to carry out numerous statistical analysis on their data. However, as with all computer programs, it's as good as the users that uses it. If you need to do any statistical analysis, I recommend you use this program and you can download it for free under the campus license agreements of TU Delft. In order to do that, you have to go to Blackboard and then find the campus software under there. So, what are we going to do in this class? Well, in this class we're going to look at your own small analysis. If you want, you can click along with me. Simply install SPSS on your machine and you can mirror the analysis. In order to do analysis, we need some data. So I am using the data of a questionnaire that was filled in by students of the face-to-face version of this course in week 1 of the lecture series in period 4 in the year 2012-2013. The questionnaire, its codebook and the SPS data file of the answers to the questionnaire can be found on Blackboard, so if you want you can see exactly how we came to the answers that we have. So what I'll be doing in this part of the lecture is switching between the different screens on my computer. So I'll be swapping from this PowerPoint presentation to SPSS and if necessary the codebook in Excel. So how do you enter data into SPSS? Well, SPSS on its looks, as I'll show you in a minute, basically looks like a big Excel worksheet. So what we're going to do is fire up SPSS, open the file we're asking for, or choose a new file, and then you see the different tabs. So here we go. So I'm now looking at SPSS, and it is the data file that you can see also download from Blackboard. And as you can see here at the bottom, we have a variable view and a data view. In the variable view, you define all the variables, more or less like declaring variables in a computer program. So in this you see the variable ID, which is basically the number I gave to each survey as they came in. So the first survey that was handed in to me got number 1 all the way till the end. This is so that I can find back which survey belongs to which line of data. And the next variable is called YAE, and that answers the questions, why did you choose aerospace engineering? And then the program allows you to give all the different values. For instance, really into aviation, most challenging, etc. So what it also does is it gives you the width. If you're entering numbers, generally speaking, 8 spaces is more than enough. But for instance, if you're entering string data, that is text data, you may need to increase the width to, for instance, here 150. Decimals tells you the number of decimals you need to give in. Now, if you're working with integers, of course the decimals can be set to 0. If this is not the case, then you decide how many decimals you'd like. Standard SPSS defines 2, so you'll find yourself often correcting everything back to 0. Label allows you to label your creation. That has its advantages because it means it's much clearer for you to find where the data comes from, and when it creates its own graphs, because that's what this program can also do, you don't actually have to redo all the legends. And for the really lazy people, SPSS even comes with a spell check. Now, if you have a variable, the variable can have different values. And differently from computer programs, in traditional programming, in our case, most of the values stand for something. So let's have a look at MSc profile. You can see that the value labels, that label number 1 the value number 1 stands for the aerodynamics and wind energy department, number 2 for control and operations, 3 for space flight, 4 for aerospace structures and materials, and 5 for flight performance and propulsion. So what you see here is that you can easily label everything strongly. Then it asks what to do with missing. We'll leave that for none. The number of columns and then how you would like your data aligned, whatever you prefer. The next important one is measure, and measure comes about the type of data. Is it scaled data? Is it nominal data, so independent groups, or ordinal data? It's up to you to decide which variable belongs to what data category. So that's the variable view. Now, once you've defined all your variables, you can simply enter all the data. So you code your whole questionnaire into the different data. Now, to code a questionnaire, we created a codebook. And if I click to Excel now, you'll see the codebook. And ID stands for the identification number, and that is the handwritten number on top of the questionnaire. Why aerospace engineering? Then it gives you how I've coded all the different answers. Track profile, career employment, etc. All these things have been created in a codebook. It's always a good idea to have a codebook, whether you're working in SPSS or in a normal computer program, so that somebody else can look at your data, or if you haven't looked at your program for a while, can remember what you named certain variables. Anyways, let's try and do some analysis. So I'm switching back to SPSS, but the PowerPoint presentation tells you exactly what to click. So if you want to follow it again, you simply go into the PowerPoint presentations and follow the descriptions. Here you see the data view, and in the data view we have entered all the data from the questionnaire. So now we're going to analyze this data. So analyze, descriptive statistics, and we're going to explore. Now, in the display, you check that both is checked, and then you click on the variable, why did you choose aerospace engineering? And we move that to the dependent variable list. Then we click on label cases by, and we put the number on the survey in it. And then we look at statistics, and we ask for outliers. And continue. And then we do plots, and we go for histogram, and we unclick stem and leaf. And options button, we say exclude cases pairwise. That means that if one of the other is missing, then they won't plot the data point. And then we press continue and OK. The program now opens an output file and starts doing all its math. And depending on the speed of your computer, that goes fast or not so fast. So what you can see that on the question, why did you choose aerospace engineering? Out of the 58 questionnaires, 54 people actually filled in an answer, or 4 people didn't. That's what they call the missing cases. It also then gives you the highest and the lowest values. Now this is one of the ways you can see if you made a data typing error. There are only 5 options in the codebook, 1, 2, 3, 4, 5. So if you were to find the number 10 here, you know that you made a data typing error. In the histogram, you can see how the answers have been portrayed. And here in this diagram, the box plot, you can see the outliers. And if you were to have outliers in 10 or 15, then you know you've made typos and you can correct them. So this is one way for you to check if your data is actually solid, if there's any errors in it. That is always your first step, because garbage in is garbage out. So it's important that before you do any analysis that you check the validity of your data file. Make sure that every time you alter the data file, you save it under a new name and that you register in your logbook the changes you made from one file to the other. Always keep one copy of your rough original data. This is not only important from a practical point of view, but also from an ethical point of view. Research ethics demands that you have your original data file and that you keep it for at least 10 years until after your degree is finished. Right, now let's do some statistics. There are different statistics you can do for the different data, whether you're working on nominal data or scale and ordinal data. So we're going to start off with categorical values or nominal data. So we're going to go analyze descriptive statistics frequencies. In our case, we're going to be starting to look at two nominal data. Nominal data means that people belong to that group and only to that group. For instance, the BSc at did you do your BSc at TU Delft error? Yes. Elsewhere within TU Delft, yes, or outside TU Delft. You can only belong to one of those three groups. The same with the MSc track profile. So here we go. It's in the variables box. We go to statistics and we select minimum and maximum. And here, of course, there is absolutely no point in selecting mean. There is no average, median, also not really the mode. You could do a median in the sense that it will tell you what is the most likely group people are in, but it doesn't really tell you that much. So for now, we'll just leave it at this, and we go to continue, and we go OK. And again, you can see we had 58 valid responses. Minimum for BSc was 1, maximum was 3. MSc track profile, minimum was 1, maximum was 6. And then what you see is basically it calculates the frequency something occurs. So 34 people had their BSc from aerospace engineering. 1 hadn't completed their BSc and 23 had it from somewhere else. And then it gives you the percentage. It gives you the percentage columns and the valid percent. The percentage column takes into account also any missing cases. And the valid percentage bases its percentage on the actual answer cases. Now in our case, there were no missing cases, so the numbers are the same. If there are missing cases, then these percentages will differ. And the same with MSc track profile. For continuous variables, we can calculate more. So here again, we go analyze descriptive statistics, and then we go into descriptives, and we move some of the continuous variables in a box. For in our case, all the career employments. Now, for the sake of clarity, I will only do a few. So let's say the first 3. And then in the options button, I select that I want to see the standard deviation, the mean, the skewness, and the kurtosis. For those of you who can't remember from your statistics what skewness and kurtosis means is if you have a bell curve like this, if you follow my mouse on screen, the flatter the bell curve is, the lower the kurtosis, the higher the bell curve is, the higher the kurtosis, and the skewness means how far the measurement is skewed from the middle line. So if your bell curve goes like this, it's positively skewed, and if it goes like that, it's negatively skewed. So here we go, continue, OK. And here we see our values. And we see that the kurtosis here is negatively skewed for 2 of the variables. You see that we have 56 valids, that the mean is 4.32, standard deviation is 0.811, and all these different things are calculated. Now you may argue that you can do all this in Excel. That is of course true. But the nice thing about this package is that in Excel you have to add all the formulas yourself using the formula editor, and sometimes you have to add arguments into it. That user interface isn't extremely friendly, and most importantly, it's far more prone to mistakes. In this case, you have a validated set of software which you can use, and therefore, as long as you make sure that you put the right input variables in it, which is very descriptive as you've seen from the drop-down menu so far, the chances that you're making mistakes are far less. Another bonus of this program is that it can also make graphical views. So here we go again. Analyze, descriptive statistics, frequencies, and the variables select why did you choose aerospace engineering. I'll move the other 2 back. And in statistics, we select mean, median, standard deviation, minimum and maximum. I'll switch off. Skewness and kurtosis. Continue. Then I'm going to go for charts, and I'm going to ask for a histogram, and I'm also going to ask it to show the normal curve. We click continue and we go OK, and here we go. Here we see 54 people answered that question, 4 didn't. The median, the most common option, is that most people are really into aviation. The mean here, I've also calculated it just to prove a point. It calculates the mean, but you really have to wonder what the value is, because these are categorical values. You belong to one category and not necessarily to the other, so the mean has no meaning. So you have to be very careful what you let it calculate, because it will calculate whatever you ask it to, but the interpretation is up to you. Here you can see the standard deviation, the skewness, standard errors, etc. And here you can see the distribution. And as you can see, the distribution here, the skewness is a little bit towards that side. Now, these are of course some easy ones. Some of the ones we ask you to do next is to create a pie chart to show the MSc track distribution, a bar chart to show the BSc distribution, and to tell me what the standard deviation and the mean is on each of these career questions. I am not going to show you that in SPSS right now. That is for you to click through yourself. However, to make it easier, I have put those all in the PowerPoint presentation. So here we go, bear with me. If you download the file, you can create your own pie chart, your own bar chart, and tell me what the standard deviation and the mean is on each of the career questions. So this is what you should find. And as you notice, I've now started to also indicate the number this is based on. When you report pie chart schematic like this without any numbers in it, it is at least a minimum courtesy that you place the number on it. Because after all, if you are going to draw any valid conclusions, it would be nice to know how big your sample is. Mentioning your sample size is one of the ways in which you sort of validate the importance of your finding, with the meaning that the larger the sample size, in principle, the more reliable your data will be. The same with the bar chart. And here you see our bar chart. You see that in terms of frequency, 30-some students did their BSc at TU Delft. One, by the looks of it, hasn't finished it yet. And 20-some did their BSc somewhere else. And then the standard deviations as well. Here you can see how many valid answers you had, what the mean was, standard deviation, and the kurtosis and the skewness. So those are still really just descriptive statistics, just allowing you to sort of process the data and show off the data. You haven't actually given any interpretations to this data. As said before, all of this you could do in Excel. However, most data needs further analyzing. We want to know correlations, how does one thing depend on another, and we want to use all sorts of statistical methods. Now, of course, you can hard program into Excel or in MATLAB or in any of the other codes, but why would you? Because this software does it for you. And the nice thing is that this software also has a whole statistical rulebook with it, so that you can do your own thing. And it's important to realize that the type of statistical analysis depends on the type of data you have. So in the next slide, which will take hopefully a little bit longer to load, if it loads, there it is, you see a data chart. And this chart comes from a book I would really recommend if you're going to work with SPSS and statistics. It's a book by Andy Field, Discovering Statistics Using SPSS. And he is very good in explaining which method you need to use when. And he's very good in explaining on how to interpret the data and the conditions the data have to meet. For us as engineers, it reads like a nice, good recipe book and at the same time it helps you interpret the consequences of it. So it's a good book, and I really recommend, if you're going to work with SPSS, that you pick up a copy from the library or even buy one. So using the different charts, you can see what type of methods there are available to you. This is the most common method. I'm sure there are more, but these are the ones you're most likely to be using. So how many outcome variables have? Do you have one or two or more? You got continuous variables like age or those sort of things, or categorical values that people can only belong to one category. And then you got predictor variables, what type of predictor, etc., etc., and that gives you the different tests that you can see. So generally speaking, there's lots of things you can do. There are different charts for the different methods, so it's important that you check that the method that you use can actually be used with the data that you have. There are conditions data must meet in order for the statistical analysis to give valid results. Don't get me wrong, they'll always give results. I'll show you that in a little bit. But you have to wonder if the results are actually valid. So, one of the most common demands on data is that data is normality. So that is, the data is normally distributed. So most methods ask for this. So you can also test for normality in SPSS. I will now switch again back to the software SPSS and show you how that is done. So in SPSS, we go Analyze, Descriptive Statistics, Explore, and we'll move the ones we did before back. Yep. And we go Move Career Variables, those are all those, into the dependent list. We ensure both is selected. We click on Plots. We ask for histogram and normality plots with test and click on Continue. And in Options, occlude cases pairwise, click on Continue, and then we go OK. The program now goes away and does some analysis. And what you see is the number of valid cases, the number of missing cases, the extreme values it gives, just like a bit before. And then it gives you the test of normality. There are two tests of normality, Kokormov-Smirnov and Shapiro-Wilks, but what you need to look for is the word significant. In order the data to be normally distributed, the significance must be larger than 0.05. As you can see here, all the significance are smaller than 0.05, so none of the data is normally distributed. This is often a case in data, and this is why it's important that you also look into the statistical literature, because it will tell you that for large data files, it is not a problem to still use certain techniques, and large is then defined as n is larger than 30. So we have an n that is consistently larger than 30, so if we want to do more analysis, for instance a t-test, we can. But you must always check whether or not your data meets the requirements, and if it doesn't, whether that is a problem for your particular test in your particular data set. So, let's go on for an example. Let's say we want to find out the answer to the research question, are students who are really into aerospace significantly more likely to want a career in aerospace than students who choose a degree because it's most challenging or difficult? The test we'll decide to use is an independent sample t-test. I'm not going to go into the specifics of what this test does. If that has dropped to the back of your mind, I suggest you revisit your statistics books. But it is important to realize that there are a few assumptions in the t-test. If you want to see those assumptions, they are also listed in the PowerPoint presentation, but for now I'll stay in SPSS. The assumptions are: subjects can only belong to one group. That means students cannot be both really into aerospace and choose a degree because it's most challenging. We only allow students to make one choice, so that's correct, they're both in one group. The dependent variable must be measured at interval or ratio level. In our case, that's also good. Random sampling. You could have a slight discussion whether students attending lectures are randoms or just to show us off, but as it's the first lecture, I assume everybody turned up, so I call it random. Independent observations. This is where we assume that you haven't talked to each other and that every observation is one unique measurement and not influenced by the others. Then we must have a normal distribution. The Kolmogorov-Smirnov significance must be larger than 0.5 in this case, and the homogeneity of variance, the Levine significance, must be larger than 0.5. So, let's have a look on how to do this. Earlier, we did this check, and we saw all this data, and we can see that we're not normal. But in our case, because n is larger than 30, we can still continue. So, here we go, analyze. And now we go to the different statistical analysis. The first were just the reports, the descriptive statistics and the tables, but here we go to compare means. And we select the independent samples t-test. Let's move the dependent variable CET, career employment aerospace, to test variable and move the independent variable YAE, grouping variable, to the grouping variable. Now it's important that we ask, you see two question marks, which group we define. And we say group 1 is everybody who answered 1, really into aerospace. And group 2 is everybody who had indicated the value 2, chose to degree because it's really, really difficult. Continue. And then we press OK. And then you get a whole load of results. You see a histogram, you see career plots and all these other things. And here we see the t-test analysis. And in the t-test analysis, you see that 22 people said they were really into aviation space, and 18 because it's the most challenging and difficult degree. You see the mean score, the standard deviations. And here on the underneath, you see the independent samples test. And what you see here is that Levine's test for equality of significance is 0.002, and that is smaller than the indicator value, so it is not okay. It means, very simply said, that we can't use the t-test. So as you can see, I can calculate all I want. So any conclusions, I can't possibly make any conclusions from this. So the outcome is irrelevant. The things we would like to look for is irrelevant because we can't make statistically valid conclusions. If it was a valid significance, then this would have to be a larger value as indicated before. So, where does this leave us? Well, that leaves us with the final slide of this presentation, the moral of the story. And the moral of the story, very honestly put, is garbage in is garbage out. You have to be very careful with what data you use. You have to take the methods you are going to use your data analysis into account when you're designing your experiment. You need to have certain data. If you want continuous data rather than categorical data, you need to make, because that gives you better analysis methods, you need to make sure you design your data acquisition such that you get that type of data. Also make sure that you know what the assumptions are of each method and check that you do not violate them. To a certain extent, that is irrelevant whether or not it's statistical data. It goes for any data that you mathematically manipulate. Use the manuals provided your analysis tool, as well as other literature. Often you're not the first doing this type of analysis, and they may help you greatly when you get stuck. If all else fails, you can also always Google the problem. There are numerous forums for whichever data analysis software you use that can help you. This is the end of the lecture on data analysis using SPSS. As I said, it is just an example, and I hope you find it useful. Good luck with your project plan and see you again next week.